Yes, Ali, am I audible?
Yes, ma'am.
Okay. Ali, yesterday we started with the class, so very basic portion of electrostatics we started with, and we couldn't complete much. So let us continue further. So what did we study yesterday was that what's an electric charge? It's the basic or intrinsic property of matter that gives rise to electrical forces. Then we studied that the SI unit is coulomb, CGS unit is electrostat coulomb, and 1 coulomb is 3 into 10 to the power 9 ESU. And we saw, see, electric charge is a scalar quantity, and we had seen that there are two types of charges, positive, negative. And we know positive, positive, negative, negative. Basically, the like charges repel each other and unlike charges attract. So any doubt till here, Ali? Okay, now we'll move on to the next topic, that is conservation of charges. So when we talk about the conservation of charges, see, conservation of charges is similar, the statement is similar to the conservation of energy, we know. What was the statement of conservation of energy, what we were studying in class, which we were studying in class 11? That energy can neither be created nor be destroyed, it just changes its form and all. So similarly in conservation of charges also, your charges, when we're talking about the conservation of charges, the charges won't be created anywhere, charges won't be destroyed. It's just that from one atom to another atom, the charges will be transferred. And this transfer of charges we have to see. But before that, let us just see one thing. See, I was talking about electrons and charges yesterday. So I told that electrons hold some amount of charge. Electrons are not all the complete charges that are present. We say that electrons hold some amount of charge, right? So if I say electrons hold some amount of charge, means what is this value that the electron is holding? So this value is 1.6 into 10 to the power minus 9 coulomb. This much amount of charge is held by the electron. Now, see, for a proton and a electron, how to differentiate it, we can put the signs. See, if I put this as, for electron, if I write this as minus 1.6 into 10 to the power minus 19 coulomb, you'll be able to figure this is negative, so this is for electrons. Similarly, for protons, I can put this as 1.6 into 10 to the power minus 19 coulomb. So this is for proton. So basically this value 1.6 into 10 to the power minus 19, this is known as the electronic charge. This is known as the electronic charge. And this is valid for both electrons and protons. Valid for both electrons and protons. So this value is represented by the symbol E also. And you please remember this value because it won't be mentioned anywhere. And you will be using it the way you use the value of pi 3.14. The question does not tell it, but you already know it by yourself. So this is such value that will be used in your entire electrostatics. 1.6 into 10 to the power minus 19 coulombs. This much amount of charge should be remembered by you, and you should know that one single electron holds this much amount of charge. So 2 electrons will hold how much? How many protons will hold? These we'll see in the properties of charges in tomorrow's class. So E, whenever you see the symbol E, you can replace it with this term. E means this only. Got it, Ali?
No.
Okay. Coming to this, before you write that part, just a small portion. See, when the amount of positive and negative charges are equal in number, we say that the body is neutral, right? So this neutral term means amount of positive and amount of negative charges, both are equal in number. So to understand the concept of charging, let us just have a look at the structure of an atom. See, in the structure of atom, in the central part, we have the nucleus where protons and neutrons are tightly held. And surrounding this protonic part, see, there are various shells, or we say there are various orbits, which are present around the nucleus. And each orbit is unique for holding its electron. This is how an atom is created and how an atom is made. So in each of these, one electron is present in one of the orbits. So suppose in this one electron is there, here this electron is present, here this electron is present, and all of these electrons are present in their respective shells. So the forces that occur here is, see, the protons and neutrons within the nucleus are held very tightly and very strongly with the help of forces which we call as the nuclear forces. Okay, the first type of forces that exist in an atom is the nuclear force. This is the nuclear force. Okay, so nuclear force means this is the force which is holding the protons and neutrons. Now the problem with the nuclear force is that this is a very strong force. Okay, it's a very strong force in nature. Now the second type of force that is existing here on, the second type of force which is existing within the atom is between the electron and the nucleus. Right, between the electron and the nucleus, there exists a force because of which the electrons are able to revolve around the nucleus. So this force is the electrostatic force. So this is the electrostatic force. And if you see, in comparison to the nuclear forces, the electrostatic forces are weak forces. The electrostatic forces are weak forces in nature. Nuclear forces are very strong. Electrostatic forces are very weak. Like if you take the experimental ratio, the nuclear forces are 100 times stronger than the electric field. This is the ratio. So you tell me, Ali, if this is the scenario, will the protons be easily escapable or the electrons will be easily escapable?
The electrons will be easily escapable
Yes. Why?
because its force is weak.
Its force is weak. Exactly. It's easier to break a weaker force. So you should just remember that transfer of electrons occur. Now the body which receives these electrons, we call that body as a positively charged body. And the body that loses all these electrons, we call that body as a positively charged body. And when the amount of positive and negative charges are equal, we say the body is neutral. So these are the three types of bodies that exist. So when electrons are in excess, the body becomes negatively charged. When the atom loses electrons, so it becomes positively charged. And when all are equal, we say the body is neutral. So what you have to remember is that it's the transfer of electrons that is determining all of these things. Whether it's positive or negative or neutral, this is being determined by what? This is being determined by the electrons. So you should have this in mind that protons are not moving. Protons do not. And this process of transferring of electron from one atom to another atom, this process is called charging. We have methods of charging. Methods of charging mean methods of transferring electrons. So charging we will see in the later section. First, tell me, this part is clear?
Yes, ma'am.
Okay. And see, this is for the drawing part. I have drawn all the layers separately. See how an atom looks like is this. In the central part, see, this is how the nucleus is present. And look, these are all the electrons. So these are held like this. See, every electron And these are how elliptical the orbits are present, and these are the electrostatic forces. Within this nucleus, the protons and neutrons exist. Got it, Ali?
Ma'am.
Okay, before we start, now we are going to start with this charging, means transfer of electrons. You write down the portion. Continue it from yesterday. And just tell me once done, Ali, because we just have 1 hour and we have to complete a portion. See, Ali, now charging, I told you that it's the transfer of electrons. Now, when we are talking about the transfer of electrons, see here, we are going to talk about the positive, negative, and the neutral body a little in detail. So before that, look at this example. This is body A, and this is having 4 electrons and 4 protons. So I'll write, see the net charge here, I will write this as, see, 4 protons are there, and protons also hold E amount of charge, but positive. So I'll write this as plus 4E. And for the electrons, electrons hold that amount of charge only, but with a negative sign. So I'll write this as minus 4. So this cancels, this becomes 0. And see, mass of a single electron is 9.1 into 10 to the power minus 31 kg. This is the mass of a single electron, Me. So if 4 electrons are present in this atom, the mass is going to be 4 Me. Now, when I say this is 0, what kind of object is this, Ali? Positively charged, negatively charged? Yes, Ali?
Neutral charge.
Neutral, right. Neutral. It is neutral. The net charge is 0, right? Now, Ali, see, suppose in this atom, 1 extra electron has been added like this. Now, you tell me what's the net charge here?
Minus 1 electron.
It is?
Minus 1 electron.
Yes, it is 1 electron. See, minus 5e and plus 4e. So it is minus e. Now you can see minus. Already we are getting extra negative charge. Means this is a negatively charged one. But see, 5, because of this electron, addition of this electron, this made this also as this when this electron came in, it increased the number of the electrons. So what is the mass now? 5 times mass of a single electron. Do you agree?
Yes, ma'am.
Now see, if in a third case I have removed one of the electrons, so now what's the net charge here, Ali?
Positive electron.
Yes, 1e will be left, because plus 4e minus 3e, that will be plus e. So it means this becomes a positively charged object. This was negative. And see, because of loss of electron, now number of electrons are 3 only. So mass is 3 mp. So by this entire example, what is important for you to know and what's the conclusion? You should know here, see, when you have a negatively charged body, negatively charged body is formed by gaining of electrons. Second, first point is that it gains electrons. Second point is that mass increases because the associated mass of that electron also increases. That electron is itself carrying this much of mass. So it will increase the mass of atom. And when we're talking about a positively charged body, this is formed by loss of electrons. And since electrons are losing, the mass decreases. Tell me, Ali, this part is fine? Did you understand this?
Yes, ma'am.
Okay. Now we have 3 methods of charging: by friction, conduction, and induction. So I'll start with friction. First, you just write down this part. Okay, Ali. Let us just start with charging by friction then. So these are the three methods of charging. You can copy it later. See, when we're talking about charging by friction, what was the friction force? Friction force you studied in class 11. We have that discussed it. What do you remember about the frictional force?
And it is the friction. No, it is the force by two objects when
Yes, contact force
when
between two objects. Yes, and what else? Main function of the friction force. How is it different from the rest of the forces? See, it opposes the motion. No? Wherever is the direction of motion, frictional force acts in opposite direction. Yes, Ali, right?
uh,
So see, in charging by friction, basically what happens, see how is the frictional force generated? Like you were mentioning, because of contact between two objects. So if I have two objects, I have two spheres, okay, and I'm rubbing them against each other. So what will happen? Because of interlocking, because of the irregularities present, there will be a frictional force generated. So work is done against the frictional force. So what happens? The valence electron means the electron in the outermost shell, right? That electron, this electron which is there. When heat is created, see, frictional force is itself a dissipative force. It's a non-conservative force. So whatever is the work done in overcoming this frictional force when two objects are rubbed, electron gets transferred from one body to another. So you need not go into the mechanism. I'll tell you what kinds of questions can come. See, usually the questions do not come. Means sometimes the questions have come from this topic. So that part I'll tell you what kind of questions are there. The kind of questions that come from frictional part is that, okay, Ali, tell me, in both the bodies, what's the net charge?
I'm at zero for the first one,
Hmm.
zero for the second one.
Yeah, both are neutral. So both of them are neutral. But how, see, suppose I have these two objects, A and B, and now we know the charge on both them is that both of them have the net charge as 0. Now see, if I have these objects and I rub them, I rub both of these. I've rubbed both of these charges together. Sorry, both of these objects together. There's a condition that I'm giving you. I am telling you that the electrons which are present in object B, in this B, they are strongly bonded. So you tell me, from where will the electrons be easily able to move? From A to B or B to A?
A to B.
A to B. Because here they are tightly fixed, all of these electrons. This can easily move. So again, see, okay, I'll show you this. If electron, according to you, electron is moving from object A to B. This is what has happened. In order to maintain the amount of charges, since B had strongly bonded electrons, the electron transferred from object A to object B. So which will become positively charged and which will become negatively charged?
A will become positively charged and B will become negatively charged.
Yes, A becomes positively charged, B becomes negatively charged. So these kind of questions are only there. You just have to identify the charges. These kinds of questions can come. So what's the main point that you need to remember is that, see, that's it, that if B has strongly bonded electrons, so easier is the transfer of electrons from A. Electrons are getting transferred, means it is still following the conservation of charges. Conservation of charges. And see, for all the objects, you need not remember which will be positive, which will be negative, but at least you can remember for glass rod and silk cloth and woolen cloth and plastic rod. These are present in your NCRTs. Nobody's going to ask you that, but just in case if it comes, glass rod, see, on this once this experiment was done, it was concluded that glass rod becomes positively charged and silk cloth becomes negative. charge. So tell me, Ali, from where has the electron moved among these?
From the glass rod to the silk rod.
Yes, from here to here. Similarly, woolen cloth becomes positively charged and plastic rod becomes negatively charged. One numerical, one not a numerical, a question that has come, and a sort of question. See, these kinds of questions can only come from charging by friction. This says that if an object made of substance A is rubbed with an object made of substance B, this is A, this is B. They both are rubbed against each other. What is the result? The result is that A becomes positive, B becomes negative. Okay. Then it says, however, an object made of C is rubbed, then A becomes negatively charged. It is saying if, however, an object made of substance C comes, means A and C, they are rubbed against each other, then A becomes negatively charged. So obviously C will become positively charged. It is asking us if B and C, they are made to rub against each other, what is the final charge on these two? So Ali, see, if this is positive, this is negative. So like you were answering the concepts already, you tell me from where has the electron moved once they were rubbed?
A to B.
A to B. So which has strongly bonded electrons?
A.
A. It has
Oh,
strongly
B.
bonded
B.
electrons, so it allowed electron to move.
No, ma'am. B.
B. So B has strongly bonded electrons. Strongly bonded electrons. And here in case of A and C, what do you think? Which has strongly bonded electrons?
A has strongly bonded.
Yes,
No, ma'am. A has strongly bonded electrons.
A. A than C, right?
No.
Now, Ali, look. B has greater bonding of electrons than A, and A has greater bondings than C. So if we compare just B and C, B has strongly bonded electrons than C. So you tell me, what should be the final charge on both of these?
B will be negative and C will be positive.
Perfect. Because from electrons will transfer from C to B. Got this whole concept clear? Charging by friction?
Ma'am.
Okay. Write it, Ali. Questions will also be, the homework questions will be there today. Yesterday I didn't give any homework. Today the questions will be there. Please write down this from here, methods of charging. Then I'll start with conduction. Okay, Ali, now coming to charging by conduction. So in charging by conduction, there's just a slight difference. Instead of rubbing the objects together, what we do, we just place the objects in contact with each other. So due to the contact, the electrons get transferred. Now in your syllabus, if two objects are getting charged by conduction, the objects will be identical. Means in your syllabus you'll only get identical objects. So if you have identical objects, means two spheres having same radii or cubes having same sides, like this. So if you have identical objects, then the charge distribution, like once they are put under conduction and then they are separated, the amount of charge received by each body will be the same. For example, this is plus 4e, this is 0. So what's the total charge? 4e plus 0 equal to 4e. Now this total charge has to be distributed amongst two. So that will be 4e by 2, which is equal to 2e. So after conduction, this will receive plus 2e and this will receive plus 2e. Did you get it?
Ma'am.
Like, let's take one more example, 4e and minus 80. So what's the total charge? 4e
4e.
minus 80 minus 4. Yes. And when minus 4e is distributed among 2, so this will receive minus 2e, this will receive minus 2e. Fine.
Yes, ma'am.
Now let's see a question. This says that two identical spheres, A and B. Now see, it has mentioned the term identical. Means you can use whatever we have studied. A and B. And what are the charges on A and B? A is having plus 4e charge. B is having minus 2e charge. Okay. These are the two charges. Plus 4e on A and minus 2e on B. Then it is saying a third charge, a third sphere, which is also identical. Okay, this is also identical, but this is not charged, is first placed in contact with A. Means first they are placed in contact, conduction occurs, and then when they are separated, C and B are put together. So Ali, you tell me, when first A and C are, and we have to find out the net charges on all of these. So Ali, you tell me, when A and C are put in contact with each other and the process of conduction occurs, what are the charges on them after
2e
conduction?
and 2e.
Yes,
2e.
2e on both of it. This will also receive 2e, this will also receive 2e, because we have 4e plus 0 divided by 2, which is equal to 2e. Now, Ali, this is saying that these are connected. So what will be the final charge on B and C?
0.
0. Minus 2e plus 2e divided by 2 is simply 0. Here also this will become minus 2e plus 2e divided by 2. Total charge by 2, 0. So ultimately, what's our final answer? A becomes plus 2e, B becomes 0. This C also becomes 0. This will be your final answer. Am I clear, Ali?
Yes, ma'am.
Okay. Just a small part of charging by induction is left. I'll just discuss that. You write this. Okay, Ali, the last part for today, charging by induction. So we'll just discuss the theory part, the numerical and the questions we'll discuss it tomorrow. So you'll be joining the batch tomorrow. So there we'll discuss. See, in charging by conduction, what happens? See, this is an object. Let's say this is a conductor and this is holding positive and negative charges. So it is holding equal amount of positive and negative charges. What are these? These are the positive charges and these are the negative charges. So if all of them are equal in number, we say the body is neutral, means the net charge is zero. Net charges. Charges are present, but net charge is zero. I have brought a positively charged glass rod. I had a glass rod and I made it positively charged. Okay, and I just brought it near the conductor. So positive charges will attract what kind of charges?
Negative.
Negative. So after a certain period of time, all the negative charges will start to accumulate towards the end of the glass rod, right? Gradually, what will happen? I'll be easily able to separate the positive and negative charges. Will you be able to do that? Positive and negative charges will be separated in this manner. So this process where nothing was present here, this was neutral. But when the charges came, received the opposite charge and the other side received the opposite charge. This is called as charging by induction. Look, this was neutral. This side was also neutral. This object was neutral. But now this side is negatively charged. This side is positively charged because of the presence of this. So this process of separating the charges, or you can say electrifying the charges, is called induction. Now, the charges that have been separated, these charges, these are called as induced charges. Okay, these charges are called as induced charges. And the charges that have separated them, these, with the help of this only, it was able to originate. These are called as inducing charges. And both negative positive charges have separated. Just one more thing, Ali. If I am holding this glass rod and this is the conductor, the charges are separated, negative on this side, positive on this side. But as soon as I remove this glass rod, there is nothing to hold the negative charge. So negative and positive, they'll recombine and it will again become back to neutral, right? This will again become positive and negative, right? So it means till the time I'm holding the glass rod, the charges are separated. So we say this process is called as this process is basically temporary electrification of charges. Got it?
Yes, ma'am.
You just write it till here. The numericals part and all we'll see tomorrow. Ali, I'll share some questions today based on the topics that we have done today. Please try to submit it. Then I'll discuss it tomorrow. Okay, Ali. Then let's meet tomorrow and continue. Okay. Do you have anything to ask? Any doubt?
Mm.
Yes, Ali. Everything is clear to you?
Ma'am,
Okay, Ali. Then okay. Thank you. Then love is.
thank you, ma'am. I love.